All right, going to finish up this last example we didn't do yesterday. So this is related to the sum and difference of cubes. Those formulas are right above the example here. You can't see it in my screenshot here, but we're going to use factoring to solve these. If you were to put either one of these two examples I have for you on the graph, you're going to see this should have 3 answers, this should have 4, but you're only going to see for this one the graph would only cross the x-axis in one place. Over here it's going to cross twice because I do have an x in here that we can factor out in a second, but the other answers will be imaginary. Whenever you have sum or difference of cubes, I wrote this little note here, when you go through and do the quadratic formula, you're going to have to do this on any of these types of questions. You can always break down what's under the square root. It'll be divisible by 3 in a perfect square. So we'll get into that in a second. Okay, so first thing I want to do is I want to factor these. So I'm just going to rewrite this real quick. This is x to the third, and 8 is the same thing as 2 to the third. So in the factoring formula that you guys see right above here, everywhere I see an a, I'm going to replace it with an x. And everywhere I see a b, I'm going to replace it with a 2. And so the factored form here, it's going to be, this is a sum of cubes, x plus 2. This will be x squared. And then it's minus a times b. So a times b would be x times 2. So I'm going to write that as minus 2x. And then b squared, this is plus 4. Okay, now right from here, one of my zeros is going to be negative 2. I can see that in that linear factor. And you will never, never, never be able to do anything more with this in terms of factoring. You have to use, to get your other two answers, the quadratic formula. So opposite of b is going to be 2 plus or minus square root negative 2 squared 4 times 1 times 4 all over 2 times 1. Now, the other two answers will always be imaginary. If we simplify this here, I'm going to have 4 minus 16, which is going to be negative 12 over 2. Okay, now however you want to do this, if you want to do a factor tree or if you want to do the biggest perfect square to break down that radical, I'm going to scooch this up a little bit so I have some more room. It's totally up to you, but I promise if you've done this correctly, this will always be divisible by 3 in a perfect square. So over here, I'm just going to rewrite square root of negative 12, negative 4 times 3. And to simplify that, because of the negative, we just can rewrite that as 2i radical 3. So here's my simplified version, 2 plus or minus 2i radical 3 over 2. Sorry about that little pop-up. And just to check real quick, don't you touch that radical, but if you're looking at whatever is in front of the radical and whatever's in front of the plus minus, if they have a common factor with the denominator, these are all 2's here, you can go ahead and reduce that. Totally doesn't matter that it has an I, you can always divide here. This would simplify 1 plus or minus I radical 3. And that's actually 2 answers. The plus and minus is 2 answers at one time. So my 3 answers, negative 2, 1 plus or minus I radical 3. Okay, and just another quick example here. Notice both of those numbers are divisible by 2, and both of them have an x. So I'm going to go ahead and take that out in front. Left over, I'm going to have x cubed minus 27. So the one we just worked through, this is a sum of cubes. Here I had to do some factoring first, but we're going to have a difference of cubes when we do this problem. Alright, so keep that 2x out in front. Here I could rewrite this as x cubed minus 3 cubed. So when I'm using those factoring formulas right above sum and difference of cubes, here a is going to be x and b is going to be 3. So I'm just going to write that in the factored form to help me answer this question. So this would be a minus b, so it's going to be x minus 3. Then it's a squared, so it'll be x squared, and then plus a times b, so plus x times 3 I would write as 3x, and then plus b squared, so 3 squared is 9. Okay, now right here, if I plug in 0, 2 times 0 would be 0, so that's one of our answers. Right here, if I would plug in 3, that would set that equal to 0. Here, you got to use the quadratic formula on this. So, opposite of b, negative 3, plus or minus square root 3 squared 4 times a times c, all over 2a. And if we simplify what's underneath here, 3 squared is 9, and then from that I'm going to subtract the 4 times 9, which is 36. So if I do 9 minus 36, I'm just grabbing my calculator here, we're going to get negative 27. Alright, so under the radical, negative 27 over 2. Now, however you want to break this down, it will always be divisible by 3 and a perfect square. So I would just do that if you want to, or you can do factor tree, your preference. Remember, when you're taking the square root of a negative number, you take out the negative by taking an I out in front. I is defined as the square root of negative 1. So that's taking care of that negative. So here I'm going to simplify negative 3 plus or minus 3i radical 3 all over 2. Now, different from the last problem, these like 3's here not divisible by 2. So this is as simplified as my answer can get here. So I should have 4 answers. You have 0, that's one of your answers. 3, that's one of your answers. And because of the plus or minus symbol, I actually have 2 different answers here. So that's my total of 4. So that's how you are going to solve polynomials involving sum and difference of cubes.